All right, welcome back, everybody. It's 5.2, verifying trig identities notes here. I wish I could teach you this in person because this is like the best stuff ever. So, if you remember simplifying trig expressions, which was literally like not even that long ago, we are basically doing the exact same thing, but instead of tapping in the dark, not knowing when to stop simplifying, we will basically tell you where to stop. In other words, we will give you both sides of the equations, okay? And what you want to do is you want to manipulate either side, right, one side or the other, to make sure that you get the same expression on both sides. Now, the one thing we cannot do is multiply, divide, add, or subtract to both sides of the unverified identity. This is basically saying, like, does this equal this? Okay, we don't know that yet, but does it equal one another? So we're here to verify those identities. So without further ado, let's go ahead and get right in. If cotan squared alpha plus 1 is cosecant squared, then this has to be cotan squared, the numerator. So let's go ahead and say that. So we use the Pythagorean identity, always the first thing we want to be looking for, okay? So this should be cotan squared alpha over cosecant squared alpha. That is cosine squared alpha. Okay. And then let's see, cotan is cosine squared over, that should be alpha, over sine squared alpha. And then cosecant squared is the reciprocal of sine, so this should be 1 over sine squared alpha. Right, as you can see, I'm not adding, subtracting, multiplying, or dividing to both sides. I'm just doing algebra to one side and using identities to exchange expressions. Well, keep change flip tells me that this has to be cosine squared alpha, or multiplying with the reciprocal, times sine squared alpha over sine squared alpha, right? And then these cancel out, equal cosine squared alpha. And then cosine squared alpha equals cosine squared alpha. So we just verified this identity. Beautiful stuff. Okay, so it's basically simplifying either side and then meet in the middle. You can work on both sides and meet in the middle. You can only work on one side. You can work on either side. It's really up to you. It's always usually easier to start with the side that looks more complicated. Here, honestly, see what we can do here. I'm going to use the old trick of multiplying with an expression that makes this into difference of squares. Excuse me. So I'm going to expand over here with 1 plus cosine theta. Alright, and as you can see, like the numerator, 1 plus cosine alpha, let's hope this sine alpha cancels out somewhere. So we're going to have the same thing here. No need to copy that. So we have sine theta times 1 plus cosine theta, and the denominator is 1 minus cosine squared theta. Okay, I'm not even multiplying the numerator out yet because I might have to factor again, so I'm just going to leave it in factored form. So what can we do here? 1 minus cosine squared theta is, yes, Hannah? Yep, that's sine squared theta in the denominator. Very good. And then we have sine theta times 1 plus cosine theta. And luckily we didn't cancel, or I'm sorry, we didn't multiply sine theta in here, because now we can say, well, this is a factor, this is, so we have, this cancels out, so we have 1 plus cosine theta, because we didn't do anything to this side, right, over sine theta, equals 1 plus cosine theta over sine theta. So we're verified. If you really want to, you can write QED, which stands for, I'm pretty sure, quod est, I could be wrong, demonstrandum something. This is Latin, basically like this says what had to be shown. You can also write it in all caps, QED. I like to do that every now and then, just because, like, if I'm really proud of my verification, I'll write it. You don't have to. It's a math thing. That's a math thing. All right, moving on. We have two more. All right, verify that. This looks like this is these two. All right, let's do it. So here, I would just want to say, like, cosecant beta, this is a beta, is the reciprocal sine, right? So this should be 1 over sine beta. And then if we rewrite all of these in terms of sine and cosine, because it looks like, well, we could factor secant here. Would that really help us? Oh, we can factor secant beta, cotan beta, right? Cotan beta and secant beta is in here, So let's do that. Cotan beta, secant beta. What's left here is cosecant squared beta minus cotan squared beta. Why is that so cool? I'm pretty sure that cosecant squared minus cotan squared is 1. So this simplifies to 1, whereas this is just 1 over sine beta. So we have cotan beta, secant beta, and cotan is cosine over sine. Always write the argument, times secant is 1 over cosine beta. That still equals 1 over sine beta. And then these cosine betas cancel out, so you have 1 over sine beta equals 1 over sine beta. Not too bad. Always work vertically, ladies and gentlemen. Work vertically, and a lot of people will write something like this, which that equals 1, but if you just don't even write that and just keep writing out what you have worked with, and just this tells me that that's 1. Like, this step in itself would tell me that that's 1. So just keep simplifying, keep working at it. All right, and then we have our last little problem. So I'm going to use, because this has secant in here and there's cosine, so I feel like we need to work with these secants. I'm going to replace tan squared x with secant squared x minus 1, because tan squared x plus 1 is secant squared x, so I can do that, over 1 plus secant x. And that equals this side, which I haven't changed yet. I like the equal signs lined up. Secant squared x can be factored into difference of squares, which this is secant x minus 1 times the quantity of secant x plus 1. Very good. And then 1 plus secant x is the exact same thing as secant x plus 1. There's no need to rewrite that though. And then this is still the same. Haven't worked on that yet. Maybe I will. Who knows? So then these cancel out. So this is secant x minus 1 is equal to, well, what can we do here? We can actually say this is 1 over cosine x minus cosine x over cosine x. Right, you can divide each term by your denominator and split up the fraction again. Well, that tells me 1 over cosine x is secant x, and cosine x over cosine x is 1, so this is secant x minus 1, which is exactly what we are trying to verify. So as you can see, this is so much fun because now you actually know where to go and where to stop, and we can, this may escalate fairly soon, but this is awesome. I love this stuff. It's great. Fantastic. I hope you're having fun with this. Hopefully as much fun as I'm having with it. Get your homework done, 5.2a homework, and come into class with questions. See ya. Peace.